All right. Today we are looking at choosing different models. So we've looked at a few different models now. We've looked at linear, quadratic, exponential models. And our goal today is to be able to construct these models based on a data set. And then to validate a model's construction. Basically saying, is this a suitable model that we are choosing it? How appropriate is it? We'll look at some techniques for comparing the appropriateness of different models. So just reminding ourselves of the three models we've seen so far. The linear model. We're going to use the linear model when data reveals a relatively constant rate of change. So with a linear model, you want the number that you're adding each time to be the same, roughly. So here we're at 1.4. Here we're at 1.4, here we're at 1.6. So it's roughly the same. We use a quadratic model when rates of change are increasing or decreasing at a relatively constant rate. So we use a quadratic model. That sounds like it's almost the same. So linear model, we have a constant rate of change. Quadratic model, the rate of change are increasing at a constant rate of change. What's that?
So constant rate of change just means the rate of change is the same throughout for a linear model, right?
I like Jude's answer. What was that, Jude? The second rate of change. The second difference. The second difference. So if the second difference is relatively constant, it's quadratic. We can also see this sometimes from the context of the question, such as it's talking about area. Exponential model. This is when the output values are roughly proportional. Roughly proportional. Now, in this case, with the linear ones, we're adding the same amount. We're adding the same amount. Now here, we're going to be multiplying by the same amount. So here we're timesing by 2. Here you're timesing by something just less than 2, but it's almost 2. And again, it's roughly timesing by 2. So this one, you're adding on the second difference. Plus C, plus C, plus C. This one is on the first difference. Linear is on the first difference. Those are your three types. Make sure you practice these phrases as well. We use a linear model that when we have a relatively constant rate of change. We have a quadratic model when the rates of change are increasing or decreasing at a relatively constant rate. And an exponential model when we have roughly proportional output values. Get used to using these phrasings. All right, so we're going to practice a little bit here at trying to determine which type of model it is. And we do that typically by making a scatter plot. So for this first one, we have to draw the scatter plot. I'm going to draw this by hand. We're going to go through 0, 11. Sorry, let me do this with a nice little X. We're going to go through 2, 8.2. We're going to go through 4, 5. We're going to go through 6, 2.3. And 8, -1. What type of model is this? Linear. We can see a linear trend line here. We would expect to see a relatively constant rate of change. So what is the rate of change in the first one? We are taking away how much? It's about 3. It's minus 2.8. And then in the next one, it's about 3 again, isn't it? It's minus 3.2. And then the next one, is it about 3? It's a minus 2.7. About 3. And here again, about 3 is a better expression, isn't it? It's minus 3.3. So it's roughly. If you look in this one, if you look between 2, instead of going up by 2 each time, if you go up by 4, you're going down by 6. If you're going up by 4, you're going down by 6. You can see it there a lot more clearly. All right. So for this one, let's plot the points. So minus 1, comma 2. 1.5, comma 5.5. 4, comma 10.5. 6.5, comma 5.75. And then 9, comma 2.25. 9, comma 2.25. What does this one look like? Yeah. This one's quadratic. Let's have a look for it in the table a little bit. I'll do the differences over here at this side. So our differences there is going to be, in the first one, we're going up by how much? Are we going up by 3.5? From here to here? 3.5? And then how much do we go up by? We go up by 5. This one. So this is 3.5. This is by 5. This one here, we're going down by 4.75. Is it 4.75? So minus 4.75. And then minus 3.5. So our second difference is, what's that going to be? Is that 1.5? Not seeing much of a quadratic pattern there. Have we made a mistake somewhere? 3 plus 3.5 plus 5. Minus. No, we have. No. However, from here to here is 1.5. And then here to here is how much? Minus 9.75. And then the next one? Minus 1.25. Plus. Not seeing that one. The scatter plot looks more or less quadratic. All right, let's have a go at doing this now using technology. So we've got the same task again, but we're going to use your technology. Take your calculator in your hand. All right, start by pressing 1. Start by pressing 1. Just press on and then choose 1 for a new document. Say no to changing. Always add a calculator. Might use that later. First up, we're going to press Control, add page, and we're going to add a list. We're going to go up to here and we type in our X, and then here Y. Type in the values 1, 3, 5, 7, 9. 10, 5.2, 2.4, 1.3, 0.7. Type your data in. Are we ready? Press Control, Add Page, and choose number 5, Data and Statistics. Let's click on the bottom and add the X-axis. And then put the relationship for the Y-axis here. What shape does this one look like? Exponential. Exponential. Have a go now at drawing the scatter plot for D for yourself. I'll give you a minute for that one. Okay, we should have typed that one in. I'm typing it in this time, giving it, instead of calling X and Y, I'm just going to use the letters A and B, so I haven't deleted my old data. And then I'm going to add my scatter plot. This is A, and this is B. What does this one look like? This one looks exponential. You can, if you wish, find the, if we can analyze this and find the regression model. And if you want an exponential regression model, we can see it going through here. I'm just going to press Document 7.2 and change the float down to 3 significant figures. Looks a little bit neater there, and we can see that's a nice exponential regression model fitting there. Okay. All right, let's move on to the next one. So we're looking at residuals next. Some of you have you seen this in AP Stats yet? Yeah, okay. Residuals, yeah, all right. So what we're talking about with the residual for the rest of us is when we create a model, we can use our model to predict values for the dependent variable given a particular value for an input. So you put your input in and you can get your output. This gives you a prediction. When using a model, it's important to remember this is only a prediction. It isn't true. We're predicting what the value is likely to be. We're not going to be 100% accurate. Depending on the type of data involved, the degree of accuracy will vary. But we want to determine, do we have the right type of model? If we use the input value for a known data point and we predict a value and we compare this to the actual value that is measured and then find the difference between these two, this is called the residual. So the formula for a residual is the actual output value minus the predicted output value. We're going to have a go at calculating a couple of those now. Okay, so for this example, we've got the weight of newborn babies, which is modeled by a linear function for the first 4 months after birth. Selected values of the height, WT, in the kilograms of particular newborn babies are given in the table. So we're going to find, using regression, a linear model for this data. Let's have a go at doing that now. So let's start off. So let's get our calculator again. Do you remember how to do this one? I'm going to press Add Page. I'm going to add a new list. I've already got an X and Y, so I can't use X and Y again for this one. I can, if I want to use X and Y again, I just press On and press New and say no. So now I can use it. If you wish to do the same, it's up to you. Otherwise, call it C and D or something. So I'm going to call this one X. I'm going to call this one Y. Type in my values, 0, 1, 2, 3, 4. Here we got 3.2, 4.2, 5.1, 5.8, and 6.4. So we typed our data in. Now to find the model, I usually prefer to do it on, we saw that we could do it on the actual stat plot, but we know we're going to make a linear model, so I'm going to go straight to it here with statistics, stat calculations, and then linear regression. 613. Menu 613. In the dialog box, the X list and your Y list, and then note what function you're storing this in. I'm going to be storing this one in F1. It's important to see where you're saving the regression equation to. So there we have our model. I can write this one down. We should write this with y hat. For the sake on the keyboard, I'm going to miss that. We've got 0.8x plus 3.34. This is the model. So we're going to use Jude. Oh, I see what you're saying. All right, I'm with you. I guess it says write it in this form, so why not? Yep.
If you pre-calculus or you worked out for not included y hat?
No.
But stats you are.
Yeah.
Okay.
I would ask that you do it as well. Let me add it now. This is y hat, which means it's a predicted value. It's a predicted value. It's not the actual y value. Let me just finish this question and I'll take it. Okay, so we are now going to use this model to find what it will predict the weight of the baby to be when the baby is 2.5 months old. So let's use the model now to make this prediction. So what we're going to do here is we're going to find y of 2.5. That would be 3.34 plus 0.8x, and our x value this time is going to be 2.5. So on the calculator, it's a lot easier to do. We just press the variable button here, above the 9, the variable. I said, remember where we saved it. We saved the regression equation to F1, and then we just type in 2.5, and it will give us our value. So our answer here is 5.34. No. But like I said, always, let's have the units. And let's add the hat. Y hat. Because this is a predicted value. This is the correct symbol for a regression equation. No, you can also put it on and it could mean an angle. Sam. All right, so this is the important part. So one of our goals from today is to look at, let me just highlight it up here. One of our important goals for this one is that you can justify a model's appropriateness by using the residuals of a regression. So we are looking at how to calculate the residual of a regression, and then we'll see how to use these values in a minute. So in order to calculate the residual of our regression, we need the formula. Now, if you refer back to the formula here, it's the actual output minus the predicted output. So the actual output is given here. The actual weight of the baby is 5.5 kilograms. So our residual equals actual minus predicted, which is 5.5 minus 5.34. So the length of our residual, we'll find that one here, 5.5 minus this number, 0.16. 0.16. So just looking at the residuals, we don't have them here. All right, so we're going to look at using the residuals to check the appropriateness of the model. And basically what we're looking on this one is a residual plot shows all of the residuals for a data set can be used to determine and help with the prediction whether the model is appropriate or not. If a model for a given set of data is appropriate, the residual plot will appear without a pattern. It will appear without a pattern. It means they'll be randomly scattered up and down. If they seem to form some type of a pattern, like a quadratic or something, then that means that this is not an appropriate model. It's showing that there is an underlying element that we have missed. With the nature of scatter plots and regression lines, the data items should be evenly distributed either side of the regression line, and then in no particular order. We don't want to see them all above and then all below. We want to see them bouncing backwards and forwards. So let's have a look at some examples. So if we look at this residual plot here, this residual plot is given. Would we say that so an exponential regression was used to model a data set. The residual plot for the exponential regression model is shown above. Which of the following is the best conclusion about the appropriateness of the exponential regression model on the corresponding residual plot? So what we see here is that, look, we're above, then below, above, then below, below, above, above, below, below. It's very random. And the spacing, the lengths of these is very random. So this shows that this is an appropriate model for modeling this data set, whatever the data set was. So we would say that the exponential model is appropriate because the residuals show no pattern. So this is what we're looking for in this one. Let's see, do we have any of the... I haven't. Let's have a look at the one that we made here. So the one that we made here, we see that what the residual plot looks like. So if I add the data set, this was X and this was Y. We had our data looking like this. We were told that this one was linear, so I'll put a linear regression through it. So let's put a linear line through it, show linear in that format. There we go. There's the linear model. Can we see that? You can just see the residuals by hand. This one is below, this one's above, this one's above, this one's above, and this one's below. Now, is there a pattern to that? Let's do the residual plot. So if we go to analyze residuals and show residual plot, look at the pattern. Well, here is the line. So it was below, above, 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 and below. But also look at the length of the residuals. Look at the length of the residuals. So we're looking at the distance between this 0, 0 line. I wonder if I can just go straight to the residual plot. I don't think I can. No, I can't. No. What we see on this one is, what pattern do you see on the residuals here? That's a quadratic. This would be an example of a pattern, meaning this is not a good model for that data. This is not a good model for that data. Let's try a different model and see. Well, no, let's not. Let's move on. It's Friday. We don't have much time. All right. So linear regression models, quadratic regression model, and exponential regression. So a group of AP students use a set of data to create a linear, quadratic, and exponential regression model. After creating the three models, the students created a residual plot for each model type. Based on the three residual plots above, which model was most appropriate for the data? Give your reasons. Discuss with the person next to you.
Which one's the best model? Those are the residual
Sorry, let me finish the video and I'll come and help. All right, what do we have? What do we think it's going to be? Jude. Exponential regression model. Why?
Well, because it shows the most scattered points compared to the linear and quadratic.
I don't think scattered is the best word because they're all scattered.
It shows the least, like, it doesn't show any pattern.
There is no pattern. There is no pattern. This is the phrase that you want. There is no pattern to the placement of the residuals, or in the residual plot. There is no pattern in the residual plot. All right, last one for today. Mr. Smith hopes to make it to the Guinness Book of World Records by painting the world's biggest mural on the sides of several downtown buildings. His mural will consist of many painted circles of various sizes where each circle is painted in a different color. He wants to create a model to determine how much paint is needed for a circle of radius r. Should Mr. Smith use a linear, quadratic, or exponential model in this situation? Discuss with the partners. What's the reason? Okay, let's hear some answers. What do we think? What do we think? Let's see some hands.
Could it be linear? Because when you're drawing a circle, each point of the circle should be ubiquitous to length to the radius.
You're painting, you're not.
Yeah, you're painting. So then the amount of paint you need is
You have
not
to paint the inside as well.
You have to paint the what?
The inside.
Oh, you have to paint the inside as well.
You?
I don't know. When you have to paint the inside. Oh,
So can I give my reasoning?
Okay, so you were thinking it was linear because you're only painting the circumference of the circle. Then you'd be right, but we're not. Let me take some. No.
I feel like the circles are 2D, so what did we call that?
Yes.
You got that one?
Yeah, you got that right. Well, we have a question.
Wait. We're painting area.
oh.
We're painting area. What's the formula for the area of a circle? R squared. Based on the radius, the relationship between radius and the area is R squared. It's clearly quadratic.
Yep.
Right. After creating his model, Mr. Smith uses it to purchase several different paints of different colors for his mural. In this situation, do you think it is more appropriate for the model to underestimate or overestimate the actual amount of paint needed? Give a reason.
It's a model, not like the action. Overestimate, so you are extra. Never be too prepared. Because paint's a liquid, so you have extra and softer glass.
Mr. Smith, das haben Sie auch noch im Wort, ne?
You can never be too careful.
No?
Thing is, the paint's a liquid.
Yeah, imagine like you run out and then like it's like a problem.
Okay, let's take John. What do you think, John? Better to overestimate or underestimate? Why?
Because, like they said, if you underestimate, you run out.
Yeah, you don't want to run out. So, overestimate is best in this context, as you do not want to run out of paint.
So we have questions like this.
Yeah, well, let's look. I'm just going to pop back to the goals for today. And what we're looking at here is this last goal for today is that you can justify based on context whether a model is more appropriate or not. And it is better to have a prediction which is an underestimate or an overestimate. It'll be a multiple choice question, so just 2. You'll get like 4 reasons and pick the right one. It'll be one of these multiple choice questions where you're given a context and 2 of them will say overestimate, 2 of them will say underestimate, and each one will have a different reason and you have to pick the right one. For some people. Sorry. I haven't yet. Okay, there is a classwork activity on the Google Classroom for you to have a little look at. Spend the next 15 minutes looking at that. I will help you with your calculator now.